Now let's start verification from R1 enable show IP route or show IP OSPF neighbor. First of all, you can see how many neighbors are there. 2 4 4 neighbors, 2 4 4 neighbors, router 4, router 2, router 3 and router 5. Done. If I will show you the database, so IP OSPF database. So is there anyone who is not clear with this database of router 1? You can see 5 router LSAs are there. Router 1 2 3 4 5. Great. And all inter area prefix means area 1 and area 2 prefixes are coming in form of LSA 3, and ABR routers are generating LSA 3. Router 5 5.5.5 is also ABR, right? And router 5 will advertise area 0 prefixes in area, area of 2 prefix in area 0. So you can see this 5.5.5 is advertising 11, 26, and here also you can add some LAN prefixes on router number 11 for the verification. And if I will talk about router 2 and router 3, so it is advertising all 60 prefixes, 60.1.1.0. 60 are the LAN prefixes in area 1. And router 1 will perform load balancing, right, for all the 60 subnet, because cost to reach both the ABRs are exactly same. So IP OSPF border router, you can see cost to reach all the ABR routers are same, 1. And so IP OSPF database, let's suppose summary and 60.1.1.0. You can see when 2.2.2 is advertising, then also cost is what? 2, and when 3.3.3 is advertising, then also cost is same 2. So it will be performing load balancing. So IP route OSPF, you can see for 60 subnets we have 2 next hop. Clear? Rest prefixes are not there in the database and even in the routing table of R1. So IP OSPF database, you can see the database, only router LSA and summary LSAs are there. And similarly in the routing table, so IP route OSPF. Now here we have so many unwanted prefix. You can see 11, 26, 36, 51. These are prefix running on WAN link. Yes or no? These are unwanted route on router number 1. We don't need these routes in the routing table. So we will filter it. We will perform route filtering for this. For now, if anyone have any question in the database of R1, please ask. We have already covered these LSAs.
See, can you show again the database of router 1, please?
So IP OSPF database, here it is, sir. There is the topology here. See, look at the prefixes in area 1, area 2 and area 0. In area 0 we don't have any prefixes.
Sir, where is 80 prefix?
There is 80 prefix. We don't have 80 prefix. We have not performed redistribution on router number 7 till now.
Okay.
We don't have 80 prefix. This is the default configuration when just I have enabled OSPF and EIGRP without any redistribution, without any external configuration, extra configuration. We will start from here. First we'll perform redistribution on R4 for 90 prefixes. And to verify some more things, here you can do one more thing. Here on router number 1 also you can add some prefixes. Let's say 10, 10 and 10. These loopbacks on R1 in area
0.
In area 0. Very good. Config T interface, or let me that only. Interface loopback 1 IP address 10.1.1 IP OSPF 1 area 0 network type point to point loopback 2 10.1.2.1 area 0 and loopback 3 10 and area so that we can verify these prefixes in area 1 and area. Let me copy command still here and let me paste it on R1. Will it increase the size of database, like the number of LSA in database after adding the loopback, or number of LSAs are going to be same? Like you can see 5 router LSAs are there
Same.
and same, it is going to be same, right?
Same.
Only one thing will be changed. Link ID in the router LSA of R1 will increase. Right now we have 8 links.
Yes. Yes.
After adding the loopbacks, we will have some more links. Once done. And now so IP OSPF database again. You can see now how many links? 11 links, but
11.
still we have 5 routers LSA, right? Try to understand, right? The all LSAs is holding what informations, right? You will understand OSPF very well, and OSPF is very important routing protocol. Everywhere we are using it, whether it is in internal network, inside company network, or service provider network, or ISP network. Every time IGP protocol is going to be OSPF routing protocol only. This is the design for our internal company network. Inside the company network, you will have similar kind of design, OSPF area design. Otherwise, just think about the database size of R1. If like all the router in area 1 are in 0 only, and all the router in area 2 is in 0, or the router in area 5 is also in 0, right? If this all is in area 0 only, then there will be huge number of router LSA in the database of each and every router. And you know, router LSA carry detailed information of links, right? So it will utilize lots of memory, lots of resources, lots of CPUs. This is the reason why I have divide the routers logically. Area is nothing but the logical division of router, logical grouping of router to reduce the memory usage of OSPF routing protocol on the router. Done. Sir, can I move?
Yes, sir.
Now you can see router 1 is advertising all 10 subnets in their router LSA. It will, router 1 will send their router LSA to router number 4, router 2, router 5 and router 3. And then these are ABR routers. So these routers will generate LSA 3 to advertise these 10 prefixes in area 1 and area 2. In area 1 and area 2. So here on router number 2, you can verify this. You can check the database. So IP OSPF database. Here you can see the summary LSA to advertise 10 prefixes. In which area? In area 1, right? This is the summary LSA in area 0, you can see, right? Router 2 is connected with area 0 and area 1. So it has some summary LSA in area 0, and the summary LSA in area 0 is holding the prefixes of area 1, as well as summary LSA in area 1 is holding the information of area 0. Now guys, what about the prefix of area 2 in area 1? How area 1 will get area 2 prefixes? Same process, Praphul. Router 5 is going to generate LSA 3 to advertise area 2 prefixes in area 0. LSA 3. Router 1 will get it, and router 1 will advertise it to router 2, router 3 and router 4. And these ABR routers will forward it in area 1. Like you can see which subnet? 51 subnet. 51.1.1.0. If I will take you to R6, 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 and so IP OSPF database, enable so IP OSPF database, and You can see the database of R6. Router LSAs and then summary LSA in area 1. Router 6 is in area 1 only. Right, and here I am looking for 51 prefix. 51 is coming in form of LSA 3. And who is advertising this LSA? Router 2 and router 3. Really, guys? Really, router 2 and router 3 is the actual advertiser? No. R5 is converting, right, or generating LSA 3. 5.5.5. On router number 1, you can check the same prefix on R1. 51.1.0. So IP OSPF database. And here is the summary LSA. And here you can find the 51 prefix 51. Who is advertising here? 5.5.5. Router 5. ABR router. Connected with area 2. And here R2 and R3, both the ABR routers will again advertise area 0 into area 1 in form of LSA 3. So that's why here on router 2 and router number 3 or in area 1, ABR or advertiser router will change. Right? Here if you will open this LSA in detail, so IP OSPF database summary and 51.1.0. You can see here 2.2.2 is advertising. This is the prefix summary network LSA and metric is 3. So metric is 3. Metric to reach in this subnet from router number 2 is 3. Metric to reach R1 is 1. Metric from R1 to R5 is 1. And metric which is advertised by R5 in LSA 3 is also 1. So total metric is 3 from R2 to destination, and R6 can calculate now total cost. Cost to reach 2.2.2 is 1 and cost coming in the update message is 3. Total cost is going to be 4. For these prefixes, 10 prefixes, again router 2 and router 3 is going to generate LSA. Hope it is clear. And now router 6 will advertise it to router number 7. First I want to redistribute OSPF into EIGRP so that my router 9 and router number 8 will have routes. So go to router number 7 and let me perform redistribution. Config T router EIGRP S number 100 and redistribute OSPF 1 subnet, sorry, not subnet, metric bandwidth is going to be, let's say, 1000, right? Delay is 100, load 100, and reliability 100 and MTU 1500 byte. This is how we redistribute OSPF
And router
into
7 is 200. Hello.
EIGR.
oh, sorry,
EIGRP 200.
router 7 is, sorry. No, router EIGRP 100, right? I want to start with router number 4. So let me take router 4. R4. Where is R4? Here it is. R4. OSPF. Sorry, router EIGRP S number 100 and redistribute OSPF 1, and this is the metric. Now router number 9 will be receiving all the OSPF routes, and these will be external routes in EIGRP router. So IP route EIGRP. You can see all the external prefixes are coming here. Done. Let me close it. And now I am going to redistribute EIGRP 100 route into OSPF on router number 4. Again go to R4 and say router OSPF configure T router OSPF 1 and redistribute EIGRP 100 subnet, means for PLSM prefixes, classless prefixes. I can define metric type 2 and I can define the metric value 1 or 10, let's suppose, and anything else. Here we will talk about tag and route map and NSSA all limit option also today, but now this is the configuration done. Now let me show you. So IP OSPF database. Now what is happening? Router number 4. Why router 4? Yes, it is generating LSA 5. Done. Router 4 is generating LSA 5 to advertise EIGRP routes into OSPF. Great. Let me write the configuration and let me take you to R1. Now on router number 1, I am expecting LSA 5. So IP OSPF database. And here you can see the LSA 5. All the LSA 5 for all EIGRP 100 routes. LSA 5 can cross area. Yes, it can cross the area. So router 1 is going to advertise it to R2, R3 and R5. First it will install it in their routing table. You can see all the 90 prefix 90.1.1.0 and there is only one path via router number 4, next hop 14.4. Even if I will ping 90.1.1.1, then ping will work. You can see ping is working. Ping with source 10.1.1 LAN user, so LAN user can also ping it. Ping is working. Great. Now let me take you to R2. R2 will also have the external LSS, so IP OSPF database.
Excuse me, sir.
Yeah.
Before proceeding, you can show me the configuration of router 9. I am missing something.
On router number 9, I have configured
9,
the IP
solution of
addresses.
see the redistribution of EIGRP.
It is on
to,
router number 4.
Yes.
Here is the R4 configuration. So run section router OSPF. Here is the OSPF configuration.
Okay.
And so run section router EIGRP. Here is the EIGRP configuration.
Okay, good. Thank you.
Okay. So now on router number 2, you can see the external LSS. Or area is there, but is there any area ID for external prefixes? No, because LSA 5 is not limited to area. It can travel in any area except like your area type, stub area and NSSA area. LSA 5 can cross the normal area. So router number 2 is going to now advertise it to R6. Router 3 is also going to advertise it to R6. On router number 6 also we can verify the database, and so IP OSPF database, and here you can see all the 90 prefixes are coming in form of LSA 5 and the advertiser is actual
4.4.
ASBR, right? That means router 6 knows about ASBR router as well. So IP OSPF border router, yes, it knows about ASBR router. That 4.4.4 is my ASBR. And what is the cost to reach ASBR? 3. And there are 2 ways to reach this ASBR. One with this IP, one with this IP. That means what is the information? So IP OSPF database, and if you will open the external LSA in detail, so IP OSPF database external and 90.1.1.0, then you can see advertiser is 4.4.4 only. Advertiser is 4.4.4 only, and forwarder address is 0.0.0. So how LAN users will access internet? First, firewall will have one default route, correct? Firewall will have one default route towards ISP. Firewall is going to advertise this default route to R1, and let's suppose through internet or ISP my data center is connected somewhere, right? So through ISP we are learning some prefixes, the data center LAN prefix on firewall, and firewall has neighborship with R1. Firewall is going to advertise it to R1, and R1 is responsible for routing inside the domain. R1 will advertise it to R2, R3 through OSPF routing protocol. R1 is going to advertise all the router inside the company through OSPF routing protocol, because my IGP protocol is OSPF, right? So R1 is learning one default route here. Let's suppose you have configured the default route 0.0.0 for internet traffic /0 and reachable via firewall. Now if you want R1 to redistribute this default route into OSPF, then you have to configure redistribution, default information originate, and R1 will advertise it this default route to router number 2 and router number 3. If forwarder address will be 0.0.0, if forwarder address will be 0.0.0 in this external LSA, which R1 is advertising to R2, R3, if it is 0.0.0, then R2 is going to install this default route or any route coming from DC data center via ESBR router, right? Next hop will be what? ESBR R1 1.1.1, or I can say reachable via R1. One user will forward traffic to the internet. First your traffic will go to R1 and then R1 will forward it to firewall. But guys, when user is going to generate traffic for internet, traffic should go to firewall. Firewall is the gateway, right? This is the best path. This is suboptimal path. Don't you think that? Yes. So here forwarder address will be used. You will configure R1 to share forwarder address what? The IP address of FortiGate firewall interface. If the forwarder address will be the IP address of FortiGate firewall, these routers R2 and R3 are not going to install the default route via R1. Next hop will be
Via firewall.
via firewall, and your traffic will use the shortest path. Here what is happening, why forward address is 0.0 and why router 4 has redistributed the prefixes with forward address 0.0.0, because there is some requirement of forwarder address. First, the next hop IP address, like these all 90 prefixes, 90.1.1.0, 90.1.2.0, 90.1.3.0, 5.0. For these all prefixes, what is the next hop IP address on R4? R9?
R9.
R9?
R1.
R9. R9 will be the next hop. So the next hop IP address should be reachable through OSPF. OSPF. If the next hop IP address for this default route is reachable through OSPF, then definitely your ASBR router will advertise that IP address as a forwarder address. That means I am not your gateway. For now, what is happening on router number 6? Router 6 knows only one thing, that if I need to forward the traffic to this 90.1.1.0, I will forward it to 4.4.4.4, because it don't know anything else about the forwarder address. Forwarder address is 0.0.0 on R6. You can see again, only one information is there: advertiser router ID and prefix ID. For an example, default, yeah. Go ahead.
What is the difference between forwarder address and gateway?
Let's suppose to forward the traffic from router number 6 to 90 prefixes, there is one alternate path. Right? This can be the gateway IP address to forward traffic in 90 subnet. Or this is the gateway IP address. Here we have one LAN device connected like this. This interface is connected here. So my traffic should not go via this. Maybe router 6 is learning the route via R4, but actual gateway is not going to be R4. It is not mandatory that every time ESBR will be the gateway also. ESBR is advertising external prefixes, but gateway can be different. It doesn't mean that my user traffic should always go via ESBR router only. User traffic should go via shortest path, right? So forwarder address is used to advertise the next hop IP address, that hey, next hop IP address to reach in this submit will be this one. Actual advertiser, like you can see on router number 1. Let me open this router 1 database. So IP OSPF database. Look at for 60 prefix, 60.1.1.0. It is coming in form of which LSA? LSA 2. Who is advertising? 2.2.2. But is 2.2.2 my gateway? Is it the gateway? No. So IP route OSPF or so IP route 60.1.1.0. Gateway is what? 13.3 and 12.2. Gateway is the IP address. Gateway is the IP address. Here your router 6 is going to use ASBR router ID to reach in 90 subnet, because forward address is 0.0.0. 90 prefix is coming in form of LSA 5. Advertiser router is 4.4.4, and so IP OSPF border router. Whatever IP address is there to reach this ASBR, that will be my next hop IP. That will be my next hop IP address. You can see 36.3. 36.3. But if you will check route for 90, so IP route 90.1.1.0, here you can see this IP address and this IP address is the next hop. And what is the metric? Why metric is type 10 in the routing table? As metric type, I have used type 1. Type 1 metric type means use total cost. So run section. So run section OSPF. Here we have defined metric type what? While redistribute EIGRP. Okay, I have not defined the metric type. Here I can set the metric type also, router OSPF 1 and no to this command, and here I am changing metric type as well, metric type 1, so that it will use total cost. Now on router number 6 you can see the metric is now 13. How it has calculated the metric? It is reaching via ASBR. You can see, so IP OSPF database external 90.1.1.0. What metric is coming? 10. And who is advertising? 4.4.4. So router 6 is going to calculate cost or best path to reach in 90 prefix via ESBR router via 4.4.4. But if there will be forwarder address, then it is going to use the cost to reach forwarder address and the cost which is coming in update message LSA. Right, so here cost is 10, and so IP OSPF border router cost to reach 4.4.4 is 3. So total cost is 13. So that's why here it is showing 13. That means my traffic will go via ESBR router. Now R6 will advertise it to R7. On the router number 7 also we will have exactly same output. So IP OSPF database, you can see, right, advertise it, router ID is 4.4.4 ASBR, and it is also going to calculate cost like R6. So IP route OSPF, here you can see the 90s prefixes 90.1.1.0, only one path via router number 6. Great. Now R6 will not advertise it to R8 because redistribution is required. So router EIGRP ES number 200 and redistribute OSPF 1 metric 1000, 100, 100, 100, 1500. Router OSPF 1 and redistribute EIGRP ES number 200 and subnet metric type 1 and metric value I'm using 10. Right. Now on router number 8 definitely you will be getting all the prefixes, even 90 prefix. So IP route EIGRP, you can see all the 90 prefixes, 60 prefix, all the 90 coming in form of EIGRP update message. Good. Let me write the configuration once here. Close this console. Close this console and come on router number 7. Now router 7 will also generate LSA 5 to advertise 80 prefix. So IP OSPF database. Now here in the database you can see external LSA, right? Some external LSAs are advertised by 4.4.4 and some are advertised by 7.7.7.7 like 80 prefixes. Good. Now R7 will advertise these LSA5 to router number 6. Let me take you to R6. So IP OSPF database. Border router, you can see now 7.7.7 is also ESBR, and so IP OSPF database. In the database you can see the LSA 5 generated by 7.7.7. Now R6 will advertise it to both the ABR, and both the ABR will advertise it in backbone area. So router number 1 will also have 80 prefixes. So IP OSPF database, you can see the external LSAs 90 prefix and 80 prefix. 80 are coming from 7.7.7.7, and so IP route OSPF. In the routing table also you can verify 80 and 90. For 80 it is performing load balancing because two ABR routers are there, and for 90 only one path, and I can forward traffic in 80 subnet also 80.1.1, 80.1.1 and source 10.1.1. Now R1 will advertise these external LSAs to R4. On router number 4 also I will have external LSAs. So IP OSPF database, and we are already redistributed OSPF into EIGRP. So these all OSPF route will be redistributed into EIGRP, and router 9 will also have the 80 subnet. So even if you will check the communication between router 80 and 90, ping should work. Enable ping 90.1.1 and source 80.1.1. You can see ping is working properly. Anyone have question to understand how EIGRP S number 100 route reaches in 200 EIGRP 200, and how EIGRP 200 route reaches in EIGRP 100 through OSPF area 0 and area 1? Anyone have issue? Who will tell me this? So IP OSPF border router. Or router 1 got to know about R4, that R4 is the ESBR. Through which LSA?
LSA 5.
LSA 1. Router 4 is going to turn on E bit in their router LSA. So all the router in area 0 can understand that router 4 is the ESBR. ABR router will generate na LSA 4.
Which bit, sir?
Yeah, 4.
E bit. ESBR router
Four.
on E bit, and ABR router turn on B bit in their router LSA.
Yes.
Now if I will talk about this area 2. So in area 2 also you can see on router number 11 we will have all the LSAs, LSA 5. So IP OSPF database 4.4.4 and 7.7.7. It can also reach to 80 and 90. Ping 80.1.1, ping is working. Ping 90.1.1, ping 1.1, and you can see is working great. Now let me take you to R1, and okay, leave this for the default route. I will come on this soon. Now in area 1, I want to reduce the database size. Let's suppose R6 is using their 90% CPU. So IP OSPF database, because of database you can see the size of database. So many summary LSA, so many external LSAs. I want to filter. Can I configure a stub area? Let me start with area 2. Let me take you to router number 11. On router number 11, see the database size. So IP OSPF database. Again the database size is large. I want to reduce it. Can I configure a stub area? Yes, I can configure a stub area, or if you have so many LSA3, you can configure totally a stub area. Let me first configure a stub area. Router OSPF 1 and area 2 stub. What will happen? Neighborship will goes down. You can see, because stub flag is not matching, So let me take you to R5, R5 and R12, R5 enable. So router OSPF 1 area 2 stub. Now soon neighborship will come up, and here you can see now on router number 11. So IP OSPF database. What happened? All the external LSAs are removed. You can see the database now. Correct? Because in stub area, LSA 7, sorry, LSA 5 and LSA 4 are
4.
not allowed. So my database is reduced. Then how I can now ping to 80 or 90 prefix? Because earlier those prefixes was coming in form of LSA 5. Now that is filtered. So what happened here? Your ABR router has generated one default route in form of LSA 3, and with the help of this default route you can still ping the 90 and 80. Ping 90.1.1, you can see ping is still working, and ping 80.1.1 ping is still working. Summary LSAs are there. So let me configure totally stub area, router OSPF 1 and area 2 stub no summary. Do so history. Let me copy and let me paste the command on. What happened? Router OSPF 1 area 2 stub no summary, and do so history. Why the command is okay? Let me run the command manually on router number 5 also. Otherwise you can see neighborship is still up because stub flag is still matching. Area 2 stub no summary. Even it is not required to run on both the router. And now on router number 11, if you will check the database, then you will see, oops, now you can see the size of database. Only one default route is coming in form of LSA 3. That's it. Still I can forward traffic to 80.1 or 90.1 or in area 010.1. But this router number 12 will not have route because here stub flag is not matching. OSPF neighborship is down. Go to router OSPF 1, say area 2 and stub no summary. And now so IP OSPF database here, just it will summarize the database. Just wait for few seconds, or you can clear the process. Now you can see here on router number 12 on my border router LSA 5, router LSA default route. Who is generating this default route? 5.5.5 router number 5, the ABR. And on the ASBR router you can see these external prefixes for 80 prefix and 90 prefixes. Let me clear the database once. Clear IP. Okay. Router OSPF 1 area 2 stub, sorry, no summary, and here IP OSPF process. I am expecting those LSAs. So IP OSPF database. Okay, it is in area 5, not in area 2. In area 2 you can see, in area 2 we have only one default route. Done. I was assuming here we are running different routing protocol, but this is OSPF area 5, OSPF only. So this way here we can reduce the size of database in area 2. I can't configure NSSA area here. Sorry, I can, extremely sorry, I can configure NSSA area as well, but I can't configure stub area to area 1. Now I want to reduce the size of database on router number 6, let's say, in area 1. In area 1, can I configure stub area on R6? No, you can't. Because if you will configure this area as a stub area, then there will be issue. Your ESBR router will not generate LSA 5. That's why you should configure NSSA area. In NSSA area, ESBR router will generate one new LSA, that is LSA 7. Let me show you here. I am going to configure now. And guys, there is no any change in area 1, in area 0, and in area 2. I have only configured area 2 as a stub area, totally a stub area. So we have filtered LSA 4, 5, and 3 in area 2. That's it. Rest all the area have same topology, same database. Now I am configuring area 1 as a NSSA area. Router OSPF 1, area 1, and NSSA. OSPF neighborship will goes down. You can see. Now go to router number 2. And here also run same command. Router OSPF 1, area 1, and NSSA. Go to router number 3. Router OSPF 1, area 1, NSSA, and router number
Area 2. Area 2.
no
Sorry,
area
area
1.
3. Oh, yeah, area 3. Yes, right. Thank you.
Router number 7. You have to go through recording of this video once, I think, because just we are testing, by the way, the previous topics. Router OSPF 1 and area 1 NSSA area. And now here on router number 6 or on router number 7, if you will check the database, let me show you the database of R6 only. Neighborship is still up again. And so IP OSPF database. You can see we have summary LSA. There is no any change in LSA 3. But we don't have LSA 5. We don't have LSA 5, Praphul. What about 80 prefixes? We are getting all 80 prefixes in form of LSA 7. Now my ESBR router connected with NSSA area is generating LSA 7. That's great. But what about 90 prefixes? For 90 prefixes, my ABR router is not generating summary LSA this time. Where is summary LSA? Not there. Can I ping to 90? Ping 90.1.1.1. What happened, guys? What happened here? Now in NSSA area we are not getting 90 prefix. So IP route OSPF area 0 prefixes are coming, but EIGRP 100 prefixes are not coming. And you can see the LSA 7 prefixes are installed in routing table with symbol what?
Because NSA blocked the LSA types 5.
Exactly, right. And this time my ABR router will not generate default route in form of LSA 7 in the NSS area, that is for stub area. Here what I can do, how I can forward the traffic? Manually you have to tell to your ABR router to generate one default route. Like go to router number 2 and router OSPF 1 area 1, which area? NSS area, and put question mark. What it's saying?
Default information with me.
Yes. right? This translate option will work for the translation of LSA 7 into LSA 5, because guys, understand, now we are getting these 80 prefixes in area 1 in form of LSA 7, and LSA 7 is not allowed in regular area. So can I have 80 prefixes on router number 1? No. No. So what will happen? Your ABR router is going to translate LSA 7 into LSA 5. And there are two ABRs. So will both the ABR will translate LSA 7 into LSA 5? No, only one router will become, ABR router will become translator. Question, which ABR router will become translator? When I'm saying translator means, I'm talking about translation between LSA 7 to LSA 5. Translating LSA 7 to LSA 5. If we have multiple ABR router, then which router will become translator? Router with higher router ID. So which router has higher router ID?
R3.
R3.
R3 will translate it. In area 0, like on router number 1, if you will check database, so IP OSPF database, see the 80 prefixes, 80.1.1.0, 80 coming in form of LSA 5. And who is generating this LSA 5? 3.3.3.
R3.
My ABR router connected with NSSA area. Always keep in mind the router, ABR router, which is connected with NSSA area, will always perform translation of LSA 7 into LSA 5. And if we have multiple ABR, then ABR router with higher router ID will perform translator. By the way, you can change the translator. And even guys, even if you will check the traffic flow, so for traffic flow, it will be performing load balancing, because there will be forwarder address in this LSA 5. If I will open it, so IP OSPF database, external and 80.1.1.0, you can see there is forwarder address. Forwarder address is the IP address of actual ESBR. This time, if you will calculate the prefix through LSA 5, you can see 80.1.1.0 advertised by router 3. That is fine. If I will open it, external and 80.1.1.0, then you can see advertising router is router number 3. And it is advertising what? It is advertising what? Forwarder address. If router 3 will not advertise the forwarder address, then router 1 will have only one path to reach in 80 subnet. Yes or no? That means what?
Yes.
That means I will calculate matrix by adding the matrix to reach ESBR router. But as there is forwarder address, router 1 will perform load balancing. So IP route and 80.1.1.0, you can see two next hop address are there. It is possible just because of forwarder address, right? So whatever path is there to reach forwarder address, it will be performing load balancing over that. Got it, everyone? The use of forwarder address. If there is no forwarder address, then router will definitely use this ABR router to reach destination, this 80.1.1.0, right? So router 3 is saying that, yes, I am translating LSA 7 into LSA 5, but the forwarder is someone else. You need to forward traffic to this IP address, and there are two next hop. If you want to change the translator, you can do it very easily. Like, let's suppose I don't want router 3 to be my translator. I want router 2 to be my translator. So on router number 2, I can configure what? Router OSPF 1, area 1, NSSA, and become translate, right? Translate LSA 7 into LSA 5. It will become translator. Translate, type LSA 7, and if you will use always command, then router 2 will be always your translator. And if you want to suppress the forwarder address, if you don't want your ASBR router to advertise the forwarder address, then you can suppress the forwarder address as well. Then your all traffic will go via router number 2 only. Like see first albase. So after running this albase command on router number 1, check. Now advertiser is, who is advertising? 2.2.2. So IP OSPF database. Now you can see the translator is changed. Right? Now 80 prefixes are coming from 2.2.2 in form of LSA 5. And forwarder address is still same. And now if I will suppress the forwarder address, that's why as forwarder address is there, it is performing load balancing. So IP route 80, you can see 2 next hop are there. But if I will suppress this forwarder address, suppress, and now on router number 1, if you will check the database, now you can see forwarder address is 0.0.0, and now if you will check the routing table, then you can see only one path is there. Great. Got it? The benefit of having forwarder address. And guys, these are the things which you need to really understand for production network. Enabling OSPF, and anyone can enable it. Can check the router LSA, but here is the manipulation, and this is the game changer. If you are able to manipulate the path based on our needs, gateway can be anything. I want to forward traffic from that gateway, and for the routing, a router is responsible for routing to find the best path. Traffic can be forwarded by any device. And guys, you can learn these all things only by practice. You have to practice a lot. Trust me, right? That's why I was saying, asking you all earlier that are you guys doing the lab or not, Because now I want you to perform these kinds of labs. If I want to forward, to perform load balancing for 80 subnet in area 0, here in area 0, I have not only one router, I can have multiple router, even router 4, router 5. These all routers are in area 0 only. Otherwise,
Okay. See. Understand.
now
The
you
same
can see
routing
again it has started performing load balancing because I have removed the suppression command and I want load balancing. One more thing is there. See, sometime you will have requirement. What requirement? To limit external prefixes in NSSA area only, right? Like assume there is no any user in area 0 who will forward traffic in 80 subnets. No any user in EIGRP 100 or OSPF 2 and 5. So what I want, that these external prefixes should be limited to NSSA area. I don't want any router to perform translation, right? These routers should not translate LSA 7 into LSA 5. This is also one requirement of production. So what you can do, actually you know what is happening here. Whenever a ESBR router connected with NSSA area generates LSA 7. In the LSA 7 there is one bit called P bit. P stands for propagate. P stands for propagate, means propagate, and by default P bit is on. So if P bit is on, your ABR router connected with NSSA area will always perform translation. If you will off this bit, then your ABR router will not perform translation. That means these 80 subnets will not enter in area 0. If it will not enter in area 0, R1 will not advertise it to R4. It will not reach in EIGRP 100 also, not reach in OSPF 2 also. Right? So if you want to limit external route into the NSSA area only, you can turn off this bit. First, let me capture the link here. Which link? Let's say P0/0/2, and there are so many other things. We don't need to discuss everything. Whatever are so important are we are using generally in the production, I am talking about that only. Okay, so on router number 7, just I am going to shut down the G0/0 and then I will shut right, so that it will generate LSA 7 again. I want to show you the P bit. That's it. So go to router number 7 and a config t interface G0/0 shut down and no shutdown. OSPF is down, no shutdown. Again OSPF neighborship will come up and it will generate LSA 7. I will open that LSA 7 and I will show you the bit. Here you can see router 7 60.7 is generating OSPF update message LSA update message. Let me check which update message is there, which LSA is there, which LSA is there, LSA 7. In the LSA 7 you can see in the option P bit is set to off. Okay, P bit means propagate, it is not set. When this bit is not set, then translation will happen. I'm so sorry. When this bit is not set, then translation will happen. Means ABR router will translate the LSA 7 into LSA 5. Even here through CLI also you can verify it. No need to capture the traffic only. So IP OSPF database. Here you can see the external LSA. Means NSSA external LSA, and if you open it, NSSA external and 80.1.1.0, then here you can see in the option somewhere in the option you can see no toss capability. This is secondary thing, and here what it is saying type 7 into 5 translation means this bit is on. This bit is on. Don't know why here it is off.
Not
It's
0, right?
on.
This is LSA 1, right?
Router LSA. LSA. LSA it is. Here you can see propagate bit is
Yeah, 1.
1, right? By default it will be on only, and through CLI also you can verify it. But if I will turn off this bit on router number 7 while redistribution, you can turn it off. Here I had enable the redistribution router OSPF 1 and whoso run section OSPF. If you will check the redistribution, redistribute AGRP 200, this one, enter. And now if you will put question mark here, you can see what it's saying, NSSA only, right? If you will say NSSA only here, then it is going to turn off the P bit. If it will turn off the P bit, and here you can verify it as well after running this command. So IP OSPF database, and in the database you can see the NSSA external. If you will open the NSSA external for 80.1.1.0, now you can see what it's saying, no type 7.5 translation bit is off. So now your ABR router are not going to translate it. Go to R1. Now you will not find the route. You can see what it's saying, 80 is not in the table. So IP OSPF database means we have just limited the external route into NSSA area only. Now you can see you will not find LSA 5 for 80 prefixes. Now your ABR router will not translate because P bit is off, right? But I don't want to limit it, right? So I will move this command. I will advertise with P bit on router OSPF 1. Go to this command. Okay, and now on router number 1 again routing table. So IP route 80, and now again you can see here 2 gateway are there because there is forwarder address. Only one router, only one ABR is translating, but there is forwarder address and there are 2 paths to reach forwarder address. That's why path 4. Now again all can communicate. But what is the issue here? Lots of LSA 3 are there, so I want to filter LSA 3 also. What I can do? And guys, 1 minute. there any other options? So router OSPF1 and distribute NSSA only. Put question mark here. You can see for route map we will discuss, for tag we will discuss, and NSSA only we have already discussed, right? While redistributing route here on router number 4, I had shown you the option is the option in NSSA area. You know all the option, the meaning of all the option. About the route map is for policy, right? Routing policy, we'll talk about that. Tag is to avoid the loop, or like we are using tag in EIGRP to add some extra information. Here also we can use. Now in area 1 I want to filter LSA also, because still size of database is large. So I can say router OSPF 1 area 1 NSSA and no summary, no default route information. Translation, but it is required on ABR router only. Translation to show history, and let me the command don't what is happening. Go to R2. Here also you need to run the router OSPF 1 1 SSA summary on router number. You also summary router number 7 also. Yeah, 1 say. And now if you will check the database on router number 6, so IP OSPF database, you can see guys, now the size of database is, now we don't have LSA 4, LSA 5 and LSA 3. For LSA 3 you can see both the ABR routers are generating one fault route, right? And ping will still work. You can forward traffic, and here ping 10.1.1 yes, ping is working. Ping 80.1.1 is working. Ping 90.1.1 working. But we have reduced the size of database as well as routing table. All good? You need to explore all the option, the redistribution, the advanced redistribution, and on in the area 0 IP OSPF database map exactly 5. Again my ABR router with higher router ID is, now I can add one default route for internet access, interface P/4 no shutdown, IP address 1.1.1.1 255.255.0 IP route 0.0.0.0 which is G4 and next. And on the internet router just I am going to configure IP address and I will create one. For internet access I can configure NAT as well on router number 1. Just see the commands and later talk about NAT, like how NAT is work, so that everyone in my company can access internet. Config T, host name, internet, interface loopback 1, IP address 8.8.8.8.255.255.255.55 and interface /0 address 1.1.1.55.255. 0, write the configuration and close the console. We are not allowed to configure internet router, just configure the IP. And from R1, from the public interface, I can ping 8.8.8. But from my LAN interface, I cannot ping 8.8.8. Like if the source is, let's say, source G0/0, then ping will work. Then you have to enable NAT. Let me quickly enable the NAT, and later we'll talk about the NAT. Interface range G0/0 to 3 and 0/0 to 3. We have 4 interfaces. IP, NAT, right? These are my inside interface. Interface GG4, IP NAT, outside interface. Access list, 100 permit any source IP address and IP source match source from list 10. You the IP 4 and you overload for pack, and now ping 8.8.8.8 source 0/0. You can see ping is working from the LAN device. And now if the source is 10.1.1.1, then also ping will work. Means LAN users are able to. But can EIGRP 100 or 200 or OSPF 1, R2, R4, these router access internet? Right? On router number 6, we have default route. So IP route OSPF. Right? It can forward traffic to both router number 2 and router 3 ABR. But ABR routers don't have default route. Will drop the traffic for internet. So on router number 1, now I am going to redistribute default route into the OSPF 150 router OSPF 1 default information originate. Again, there are two things. See, you can run command like this, default information originate only. If you will use albase, when you need to use albase command when default route is not present in the local routing table. In this case, default route is present in routing table, so you don't need to configure albase. But metric type will be used to advertise the external prefixes with metric type 1 or type 2, as default is type. You don't want router should use the internal cost, then you can use type 2. If you want to use total cost, you can. Route map will be used for policy. Through metric, you can define the metric for your default route. Let me say 10, right? Metric type, I can configure 1 because I want to use. That's it. Write it. And now, if I will take you to R6, again there is no any change because we have already a default route in the totally NSSA area, and now I can ping to .8.8.8 and source 50.1.1.1. Even everyone in the company can access internet, like router number 9. Well, ping 8.8.8.8 source back 1 you is working, right? So IP route OSPF, sorry, EIGRP. One external route is coming, default route, right? So what is happening here? Now R1 became ESBR. Now R1 is also generating LSA 5. So IP protocol, you can see this router is your autonomous system border router, and it will get LSA 5. So IP OSPF database. Here you can see the external LSA 5. LSA 5, here is the one LSA 5 advertised by router number 1 to advertise default route. Will advertise to their all neighbor router 4, 2 and 5, right? And router 2, 3 are already advertising default route in area 0, no need to do anything. And router number 5 will advertise that LSA 5 to area 2. LSA 5 can cross the area. Router number 11 will also have the default route. So IP OSPF database, you can see default route coming from 5.5.5. Only one default route for, and because area 2 is my stub area, so LSA 5 is not allowed. Default route is already there. I can ping